Hey guys, welcome to this free lesson on variation. These are problems that are kind of worded like this. So they are kind of like word problems, but I don't know, they have like a very specific flow to them. So I don't think that they're totally like word problems. There's not as much modeling, like creative modeling involved. So just as a reminder, always take notes and pause to try the examples. And if you'd like, there are free guided notes available so you can just follow along, and all the examples are written out for you. So let's start by talking about what is variation. So this is a way of describing how two quantities relate to one another. And there are three types of variation. There's direct, inverse, and joint. So first things first, we need to define these. So starting with direct variation. So, okay, these have a very specific flow to the definition. So it always starts with y varies. And then what you'll notice is, so whatever type of variation we're talking about, that's what comes next. So y varies directly, and we can say either as or with x means. And so what this phrase means then is y equals kx, where this k is a constant. We call it the constant of variation. Okay, so just kind of noticing this flow, the other definitions are very, very similar, almost the same except for the equation. So moving on to inverse variation, I went ahead and filled this in already. So notice y varies inversely as x means. So very similar, right? So instead of y varies directly, now it's y varies inversely. And so for this one, it's going to look like this. Y equals k over x, where once again, k is the constant of variation. And so I would just take a moment to actually write down these definitions if you haven't. So pause the video if you need to. Then for the next definition, so y varies jointly as x and z. So now we have two letters, and what this means then is this will be y equals kxz. Once again, k is the constant of variation. Okay, so hopefully you've written those all down. And so what I want you to do is like stare at the definitions that you have for a second and notice kind of what similarities there are. So take a second, actually pause the video and just take a moment to observe. This is very important. So if I look at all these definitions, so I can also write down what the actual equation is. So y varies, so this is y equals, we said kx. Y varies inversely, this is y equals k over x, and then the last one, y varies jointly, so this is y equals kxz. Now, things to notice. They all have a k in them, right? And it all stands for the same thing. So k is always a part of your variation equation. The next thing to kind of notice is the language. Y varies, y varies, y varies, and look at this. Y equals, y equals, y equals. So this is telling you kind of where the equal sign comes. So that's an important thing to notice. And then the last thing to notice is, so what do these words directly, inversely, and jointly mean? They're all doing something to k, right? So directly means that you are multiplying x by k. Inversely means that you are taking k and you are dividing it by x. So inversely as x means divide by x. And then jointly as x and z, this means now you're multiplying by both x and z. So this is very important to take a moment to think about this. This is the idea of creating your own intuition so that a topic makes sense. You always want to do this when you're given something that maybe is a little bit foreign and all of the terms seem very, very similar. You take a moment and you just notice some patterns and you try to create your own intuition on it. So the whole thing about this is you have to really understand kind of how these are set up. Once you know how these set up, I think that the algebra kind of behind them is not as difficult. The hardest part is really knowing how to set them up. So just to kind of get you started on this, so we've got p varies directly as q. So naturally, I'm not going to use just y and x, right? I can use any letters that I want. And so we want to just be able to frame this now in our mind using the whole conversation we just had. So first things first, so P varies. So we know what that means, right? So P varies means P equals, then directly is Q. So you know there's a K in here. There's always a K. You never have to worry about that. The other letters can change, but there's always K. So what am I doing to K? Well, directly means multiplied by Q. So this would be P equals KQ. And if I do that again, so J varies inversely as L. So J varies means this is going to be my J equals, and then inversely is L. So what am I doing to K? I am dividing K by L because that's what it means to be inverse, to vary inversely. So this is K over L. So that's kind of the thing I want you to work on first, is just writing these down. This is really the key. So go ahead and pause the video and try the next two. So for C, I have H varies jointly with A and B. So H varies means that's going to be my H equals, and then jointly, so that's K, and I'm going to multiply K by A and B. Now, this next one, Z varies inversely with the square of R. So what does it mean to square something? The square of R, well, this means R squared. So sometimes people think it means square root. It doesn't say square root, it says square. So Z varies inversely, so that means Z equals, and then I have K, and I'm going to divide K by R squared. So there's the idea. Okay, so I have just three more. So once again, pause the video and try these three and just kind of make sure you have this idea down. Okay, so now I have M varies directly at the square root of N. So that's different from the square, right? So if I think about the square root of N, so now I'm just literally taking this square root here. So that's what that part means. So M varies directly. So M equals K, and then directly means multiply by the square root of N. So there would be my expression there. Next one, Y varies jointly with the cube of M and the square root of L. So Y varies, so that's going to be my Y equals, so jointly, so that means I'm going to multiply two things now by K. So the cube of M, so that means M to the third, and the square root of L. So as you can see, you can make these slightly more complicated expressions from how these are phrased. So this last one, M varies directly as L and inversely as the cube of N. So now we're being told to do two things. We're being told to, we have both varies directly and varies inversely. So that's totally possible. And if you're wondering, see, it's still just 1K. So I have M varies directly. So first of all, what does that mean that I do to K? That means I'm going to multiply K by L, and then inversely as the cube of N. So at the same time, I need to divide that by N. So this means now K is both multiplied by L and divided by N. And so this is another thing that can happen. All right. So now we have kind of the basic idea behind this. And now what I want to do is I want to walk you through like a full variation problem. And also kind of tell you what the steps are called. So sometimes when you're working with these, some problems might ask you to just complete specific steps, while others might just give you problems that look like this. It's all the same steps no matter what. You just have to kind of know what they're called. So we're going to outline all of these together. So this says J varies directly with L. If J equals 12 when L equals 4, find J when L equals 7. So step one is to set up the general variation equation. So the general variation equation is what we were doing in all of those last exercises. So it's the one that just has like the K. So you're just working with this first sentence. J varies directly with L. So that's all I care about for this particular step, just this part here. So J varies directly with L, so that's going to be J equals KL. And that's all I've got to do for that one. So that's what's known as the general variation equation. So the second step, now that I have that general variation equation, is to plug in some of the known values. So what that's referring to is this part right here. So we know how the two values interact with one another in this case. So if j equals 12 when L equals 4. So I want to take my variation equation, which was j equals KL, and now I just want to plug in the values. So this is going to be 12 equals K times 4. And so then the next step is to actually solve for K. So this will be just as simple then as looking at this as, so this is really 12 equals 4K, so I just divide both sides by 4, and I get that K equals 3. Okay, so if you're told to solve for K then, this step is kind of assumed. You can't solve for K unless you plug in kind of the known values. So that's that part. So moving on. Now what you want to do is you want to restate what we call the specific variation equation. So now that I've solved for K, I can just rewrite this as J equals 3L. So now this is the new equation that I want to work with. And then step 5 is to solve for the desired variable. So I said missing or desired outcome. What I'm really referring to here is this idea of find J when L equals 7. So this is telling you to find a specific value. So now all I have to do really is just plug in what I was given. So I've got now J equals 3 times 7. Therefore, J will equal 21. So that's your final answer. But all of these other steps are very important, so hopefully you've written them down. These are going to be things that sometimes you'll just be asked to find, so you have to know what they actually mean. Writing these steps down will help you remember them. So if you didn't do that, maybe go back and try that again. Now, just to show you what this looks like usually, so here's the problem one more time. And it's usually not as long as like the one page that I have in the guided notes. All the steps together. So here you can see there's the general equation, and then plugging in the values, and then I go through and I solve for K, and then I restate the equation, and then I plug in what I need, and now I've got the final answer. So you can see kind of all these steps here, but you know, it doesn't take up that much room. These are usually actually pretty short problems. So now what I want to do is I just want to do a couple of these. So you can go ahead and do all of those steps that we just outlined. So again, if you didn't write them down and you don't remember them, you might want to go back and watch them. Okay, so pause and then hit play when you're ready. Okay, so now I want to follow this in kind of this format, so this much shorter kind of format. I will put numbers next to it just so you can kind of see what step I'm following. So starting with the first step, so I need to state the general variation equation. So this says m varies inversely as the square of L. So remember, that's the square, not the square root. So there's my general variation equation. Now I need to plug in the information that I know. So it says if m equals 12 when L equals 2. So now I've got 12 equals K over, and this is now going to be 2 squared. So now I go through and I solve for K. So this is 12 equals K over 4. And then I can multiply both sides by 4 to cancel out the fraction here. So then for my third step, I'm getting that K is equal to 48. Okay, so now I want to restate the specific, or state the specific variation equation. So now this is m equals 48 over L squared. And so just be really careful when you do this. One common mistake is people will write the wrong equation, so they'll get the first one right, but you have to refer back to this, right? You have to use that same form. And then it says now find m when L equals 4. So that's the last step. So this is going to be m equals 48 divided by 4 squared. So that's m equals 48 divided by 16. And so we get m equals 3 is the final answer. Okay, great. So Next problem, same idea, same steps. So go ahead and pause and hit play when you're ready. So I've got A varies jointly as B and C. So first I write down my variation equation. So that's going to be A equals K, B, C. If A equals 30 when B equals 2 and C equals 5, so now we can solve for K. So A equals 30 when B equals 2 and C equals 5. So now I just have to solve for K. So this is really 30 equals 10K. And if I divide both sides by 10, I get that K equals 3. Okay, so now I've got my K, so now I have to restate the equation. So this is A equals 3, B, it's not a very good looking B, is it? 3BC. And now it says find A when B equals 3 and C equals 4. So now I take A equals 3 times 3 times 4. And so then all of that will equal 36. All right. So I have another one here. So this is one where you have both direct and inverse variation together. So once again, you can pause and hit play when you're ready. So I have L varies directly as M, so that's Km, and inversely as N, so then I divide all of that by N. So if L equals 15 when M equals 5 and L equals 2, so I've got all of this. So now I can kind of go through the steps to solve. So first I'm going to multiply both sides by 2. So I get 30 equals 5K. And I'm running out of room here, but if I divide both sides by 5, I will get that K equals 6. So now I can restate this. So this is L equals 6M divided by N. Again, I just refer back here. And now it says find L when M equals 7 and N equals 3. So I take L equals now 6 times 7 divided by 3. So ultimately I will get that L equals 14. Okay, so that should really give you a good idea of how these work. One other way you can see these sometimes are word problems like this. So I'll read it with you. So Jada's weekly income varies directly with the amount of hours she works. Last week, she earned $570 for working 38 hours. This week, she worked 36 hours. How much will she earn? Okay, so when you read this, this is literally the same as all the other problems. It's just now we put it in context. So I've got weekly income varies directly with the amount of hours she works. So you're now going to have to actually just name kind of your variables. So you have this weekly income varies directly with the amount of hours she works. So if I wanted to kind of name these then, my weekly income, this part here, we could call this maybe I for income. And then over here, we could call this H for hours. And now we can kind of reformat this, right? So I varies directly with H is really the way we can think about that, right? So the rest of this will really work the same. So if you want to pause and try the problem, go for it. So if I set this up, so using those letters I just kind of outlined, so I get income varies directly with the amount of hours she works. So there's my setup. So it says last week she earned, so that's income, $570 for working 38 hours. So there's kind of plugging in that information. So if I solve for K, so I do this, and I get K equals 15. So what does K actually represent then? This actually represents, in this case, her hourly wage. So when you're working with word problems, usually K will have something that represents in the problem. So this is her actual wage. So now I have income equals 15 times the amount of hours she works. So that makes sense, right? So now it says that she's working 36 hours, so I'll just plug that in. So I have I equals 15 times 36. And so then So her income for the week will be $540. So her income will be $540. Okay, and so that's kind of how the word problems will go. Like I said, you're going to have to actually figure out what you want to set up for your variables. So if you found this helpful, please like this video, comment with questions, and subscribe to this channel and share it with your friends. My goal is to provide free quality math instruction for everybody. So it really helps if you subscribe and share. Okay guys, I will see you next time.